All right. The check your understanding answer is um, so if we just start off with this regular isosceles triangle, if one base angle is 65, the other base angle is 65, add the two 65s together and subtract it from 180, you get 50. Now, they did not tell us where the center of dilation is. Since they did not tell us where the center of dilation is, it doesn't matter. We can make it be whatever we want. So making the center of dilation be this point right over here is really easy to see. Well, look, this angle in this reduced by 2/3 triangle is really easy to see that if this one's 65. Now remember that this triangle right here is also an isosceles triangle. So this side length and this side length are the same, so that means this is going to be 65, this is going to be 65, and this angle up here has to be 50. And the reasoning is because the angle measures are not affected by changing the side lengths. So side lengths are what changes, angle measures do not, and you will learn that for a solid fact, not just an observation in an upcoming lesson. So here they give us information that we need to use the notation. They give us the center of rotation is 0.0. They give us the scale factor of 1/4. They only give us one other point besides the center, which is point P. So P is on the image. It goes here, and it will map to P prime. Then problem number 25 says using a triangle and a dilation, how would you use the ruler? Measure and multiply. That's how we'd use the ruler. Measure the side of the triangle with the ruler, multiply that number by the scale factor, and get your new length. This one's kind of tricky. Again, you will learn something when we are dealing with perimeters, areas, and volumes that would make this a super easy problem. But since you don't know that yet, then you've got to kind of combine together some algebra and some geometry knowledge. You should remember here I've made a pre-image of a little rectangle, and then I made it 4 times as wide and 4 times as tall. The perimeter of this one is what we're looking for. So the perimeter of this one, since we don't know any of the measurements, it'll be 2A plus 2B, because you got an A on top and an A on bottom, a B length on the side, a B length on that side. So 2A plus 2B. The perimeter of that little one is what we're looking for. Well, we know that this one is 4 times as big. So the length of this side right here is 4B. And the length of this side right here, if this is A, then the length of this side is 4A. And that means that this perimeter is gonna, I have 2 of these 4A's, so that's 8A's. And then I have 2 of these 4B's, so that's 8B's, 8B's. And that is 144, because that's what they tell me, 144 inches. So I have 8A plus 8B equals 144, and I need 2A plus 2B. So this is pretty simple. I can just pull out a 4, right? Factor out a 4. That'll leave 2A plus 2B equals 144, right? So, because 4 times 2A would give me 8A, 4 times 2B would give me 8B. So just factored out a 4. Why? Because I can, and that gives me the part that I'm looking for. I'm looking for 2A plus 2B. Divide both sides by 4, and 2A plus 2B is equal to 36, which is exactly what they say. The width of the image is 5 inches, and the width of the pre-image is X. The pre-image always goes on bottom. It's image on top, pre-image on bottom. Again, I don't think that's something that you know yet. Maybe I'm wrong. Maybe I've gotten it mixed up. But when you're writing a ratio that is turned into the scale factor, then the length of the image goes on top and the pre-image goes on bottom. That was that problem that we did a while ago on one of the check your understandings that said that the ratio of one side length to the other side length was 5/2. So that's what they're doing. Again, I'm not sure where you learned that, but if you didn't learn it already, you're going to. It's coming. Sketch this. They did that over here, ABC. The center of dilation is at the origin, so that's super simple. You just say 2 times 3, 4 times 3. That is 2 times 3 is 6, 4 times 3 is 12. So go to 6, 12, and there's your new point. And you do that for all the other ones. Number 29, pretty self-explanatory. Center of dilation is at the origin. That's super easy. Just take each one of those and multiply it by a fourth. Pay attention to each one of these marks over here is a half. So some people were saying, oh, look, that's 1.5. No, that's a half and that's a fourth. So that's 3/4. That's down a fourth. So yeah, with the fractions, just be careful. 30 is right here. The dilation centered at the origin. Again, that's super easy. Just multiply this point by 1.5, multiply these coordinates by 1.5, and you'll get your new one. You can also, I don't know if you noticed this, but to get from point B right here to point A, it's 1, 2, 3, 4 over 1, 2, 3. And if I kept going, 1, 2, 3, 4, 1, 2, 3. So this one's going to be, oh, it's right in the middle. Yeah, that's probably not the best way to do it. So just do the coordinates, just like we were talking about. 31, sketch the image of a line segment with endpoints here, centered at the origin. They're giving you lots of problems centered at the origin with a scale factor of 1/2. So just multiply all those numbers times a half and get your new coordinates. Okay, this one says we've got a point, but they're not going to tell us where it is. What is the scale factor and the center of dilation? So you've got to be able to look at this and say, oh, this is my A, this is my K, and this is my A. This is my B, this is my K, this is my B. So the point that we're looking for is the point AB, and K is equal to 1/2. So the point is -5, 8. So the center of dilation is -5, and the K is 1/2, and that's what they have right there. Okay, that is the end of 17-1.